Dear friends, today we will see a new topic, that is what is actually the photoelectric effect is. So today we will discuss about the photoelectric effect. Now in this topic we will discuss that how it is discovered and how the different experiments are taken place for photoelectric effect. So first in our topic we will discuss that who discovered this effect, that is photoelectric effect is discovered by whom. So the answer is Hertz, Henry Hertz. That is, Hertz had discovered the photoelectric effect. Now we will see that how this experiment was done. So the phenomena of photoelectric emission was discovered in 1887. So 1887 it is discovered by Henry Hertz, that is during the electromagnetic wave experiments. In his experimental investigation on the production of electromagnetic waves by means of spark discharge, Hertz observed that high voltage sparks across the detector loop were enhanced when the emitter plate was illuminated by ultraviolet light from an arc lamp. So, when he was pursuing his experiment of the electromagnetic wave, when he was pursuing his experiment, its experimental setup was just like this. Here he has a spherical rod and a spherical metallic sheet. This is one induction coil. Here we can see that this is induction coil. This rod is a conductor that is providing the space for oscillation, and these spheres are working as spherical capacitor. So here one LCR arrangement was made. Now here in this region that I would like to show you, this region was called as a spark gap. Now during the experiment the sparks were being produced in this region, in this spark gap. So that in his experimental investigation on the production of electromagnetic wave by means of spark discharge, Hertz observed that high voltage sparks across the detector loop were enhanced when the emitter plate was illuminated by ultraviolet light from an arc lamp. So light shining on the metal surface somehow facilitated the escape of free charge particles, which we now known as electrons. So when light falls on a metal surface, some electrons near the surface absorb enough energy from the incident radiation to overcome the attraction of the positive ions in the material of the surface. Now, after gaining sufficient energy from the incident light, the electrons escape from the surface of the metal into the surrounding space. So, this was first time discovered by Henry Hertz, and he discovered this phenomena which is called photoelectric effect. Now, different experiments different experiments were done for that photoelectric effect. So now we will discuss that which are those different experiments which were made for the photoelectric effect. So to check that, we will discuss now the new topic, that is how many other scientists were tried to find out and apply this phenomena on their behalf by making different experiments and different observations. So out of all scientists, we first take a name that is very well known scientist of that time, that is Wilhelm Holwas. The spelling of Holwas is, that is Hallwach. So Holwas was the first experimental person, scientist, who did the experimental setup for this photoelectric effect. Now we will see that what was there in his practical. So Holwas had taken one zinc plate. So here we can consider that this is one zinc plate. Now for photoelectric effect we need basic three things. One, clean metallic sheet. So this is one clean metallic sheet. Second, surface must be glittering. So it is glittering surface is there. So surface must be glittering or polished. So it is polished surface or having some glittering part on it. Now the third condition, that is enough high frequency. High frequency must fall on this surface. So enough high frequency must fall on the surface. So it is there. So enough high frequency must fall. So now Holwas had made this arrangement for that zinc plate, and then he tried different type of experiment for that zinc plate. Now we see that what he had done. So first what he had done, he had made this zinc plate positive. So he, by some arrangement, he made this zinc plate positively charged. So now this zinc plate was positively charged. Now what he did, so we can say that he applied UV light on it. He applied or incident UV light on that zinc plate. Now after the application of UV light on this zinc plate, what he observed, this is very interesting part, that after this experiment, when he observed the same zinc plate after some time, initially it was positive. Now after some time, when he observed, so what he found there, he found that the positivity of this zinc plate increased after the incident of this UV light. So when he applied UV light on it, he found that the positivity of this zinc plate increases. So it becomes more and more positive. So initially it was positive. Now after some time of incident of UV light, when he observed it again, he found that it is more positive. Now what he did? Now after that, he make zinc plate as a neutral. So that is zinc plate as a neutral in a manner that we can say that he make whatever the amount of positive charge is there, the same amount of negative charge is existing over there, and by that mean it is neutral. Then again he incident UV light on them. So when again UV light incident on it and he observed the plate after some time, what he again found over there, now the result was interesting. Now he found that the plate which was 0 or null initially, now after some time that plate becomes positive, then it should be null only. So he found that this plate becomes more positive. That means here if we draw something, we can see here, you can find that here the electrons are missing. So his result was somehow that this plate now becomes positive. So the null plate kept and incidented by UV light, the founding result, a new result is that it becomes positive. So it was interesting result. Now after that he did another experiment. In that another experiment he take a zinc plate with negative charge on it. So with respect to positive charge, here we can say that we find some negative charge over there. So in this arrangement we can say that the plate is more negative. So it is negative plate initially. Now again after some time of the incident light of UV, so again he incidented UV light, and after this again the result was very interesting. After this he found that the plate which was initially negative becomes more positive. So here after the incident of UV light it becomes less negative. That means the negativity decreases. That means initially we can here draw that if we draw 1 2 3 4, suppose 4 electrons were there initially, suppose then after the incident of UV light we found that only few electron remains there. That means the most of the remaining electrons which were earlier here, that I am showing one electron from here, one electron from here, one electron from here, that were missing. So here the negativity decreases. That means electrons were missing. Now we will see that how the experimental setup was made. For that experimental setup, the contribution is given by the scientist named Philip Lenard. So here we can explain this experiment as Lenard's experiment. So here we can say that is Lenard's experiment. Now we will see that what this experiment actually was. So In this experiment, Linard had made one glass tube which was evacuated and enclosing two electrodes which are metallic plates inside it. So the setup was like this. Here I can draw it. This is suppose one tube. Now in this tube he arranged two plates, two metallic plates. Here we can consider it. These two are metallic plates which will work as electrodes. Now one of these portion of this tube was having one window. This is nothing but a quartz window through which a special type of light can enter. Now he made this tube evacuated and connect microampere meter with it. He also made connection of voltmeter in parallel to the power supply. Here this is a special type of power supply that can be made positive and negative, that is variable type of power supply. Here this power supply is variable. Now he put this rod as A. I give it number 1 and here I give it number 2. This plate as a C. Now this plate C is actually photosensitive material. In the beginning of this experimental setup, Linard had made plate A positive with respect to plate C. Now he incidented UV light or a high frequency light on these plates. So when high frequency light were incidented on this plate C, some electrons were emitted from the surface. So here we can say that electrons were emitted from the surface. Now when electrons were emitted from the surface, the Linard had made initially this A plate positive. So obviously the electrons which are having negative nature, they will be attracted towards the rod A and they will move towards this direction. Now obviously here the flow of electron is observed due to this high voltage applied. Now due to this, when these electrons reaches the plate A, they will complete their path and the flow of electron is obviously known as a current. So here in the circuit, the current was observed by Linard. So this was actually the experimental setup of Linard. Now again I am repeating what was there in the experimental setup. So we say that the Linard observed that when UV light radiation were allowed to fall on the emitter plate, that is C, on an evacuated glass tube enclosing two electrodes which are metallic plates, the current flows in the circuit as soon as the UV light radiations were stopped, the current flow also stopped. These observations indicate that when UV light radiation fall on the emitter plate C, electrons are ejected from it, which are attracted towards the positive collector plate A by the electric field. So here this plate A is also called collector, while plate C is also called that emitter or ejector. The electrons flow through the evacuated glass tube, resulting in the current flow, and thus light falling on the surface of the emitter causes current in the external circuit. Now, Holwas and Linard studied how this photocurrent varied with collector plate potential. So, they have also changed the potential from this power source, and the source changes the potential, and they found and they analyzed that how the current will change. Now they also observed that how the current will change with frequency and also with the intensity of incident light. Now after the discovery of electron in 1897, it becomes evident that the incident light causes electrons to be emitted from the emitter plate. Now, due to negative charge, the emitted electrons are pushed towards the collector plate by electric field. Here, electric field is produced due to this power supply. So here, as the power supply is given and the charge are produced from here, we can say that due to this power supply, initially this plate is kept positive and this kept negative. So in between them there is a strong electric field will develop, and due to that electron will start moving towards the positive plate. Now, so we can say that due to the negative charge, the emitter electrons are pushed towards the collector plate by the electric field. Now Holwas and Linard also observed that when ultraviolet light fell on the emitter plate, no electrons were emitted at all when the frequency of the incident light was smaller than the certain minimum value. So here this observation was also very interesting, that if incident light frequency is less than some certain frequency, then no emission was found. So at that time no emission was found. So this indicate that to emit electrons from a certain position, we must need a certain high frequency. So if the frequency of incident light was smaller than the certain minimum value, we can say that that minimum value, or the minimum value of the minimum value of this frequency is called threshold frequency. So this is called threshold frequency, and this threshold frequency, that is the minimum frequency, depends on the nature of material of the emitter plate. So it depends on the plate C, that how the plate C is made. The minimum frequency also depends on that plate material. Now, it was found that the certain metallic plates like zinc, cadmium, then magnesium, etc. respond only to UV light. So, certain materials which are responding to UV light only, like zinc, then magnesium, then cadmium, these are the material which are only respond to UV light. So they can only emit electrons when UV light is incidented on them, which means having short wavelength to cause electron emission from the surface. So here they are having short wavelength, and that means high frequency. So this was the case. Now, however, some alkali metals such as lithium, so we can say that another part that is for lithium, then sodium, then potassium, cesium, these were some material, and rubidium were some materials which were sensitive to even a visible light. So these materials will give emission even in a visible light also. So all these photosensitive substances emit electrons when they are illuminated by light. Now, after the discovery of electrons, these electrons were termed as photoelectrons. So, all these electrons emitted are known as photoelectrons, and they are given a name after the discovery of electrons. So after the discovery of electrons, these electrons were termed as photoelectrons, and this phenomena is called photoelectric effect.